Hello, welcome to Algebra 1 with Miss Andrea. Today we're going to continue our unit on describing data, which is also known as statistics. And this is going to be, if you're following along in the online book, Module 8. And today we're going to cover pages 5 and 6 of Module 8. So this is going to be lessons 5 and 6. We're going to cover both of those today. So starting off, what we have is we're going to look at how to visualize data. And so this is a type of what we call a normal distribution. So as you can see, it creates this bell-shaped curve. Okay, so this is a normal distribution, a bell curve, a Gaussian distribution. As you notice, it's completely symmetrical. Down, if you were to fold it right down the middle, it could fold in half on top of each other. In the middle is where you find the mean, the median, and the mode. And we never really got too much into mode, but mode is what, remember, mean is the average, median is what's in the middle, and mode is what appears the most. Okay, so this is a normal distribution. This is skewed to the left. And if you remember what skewed to the left means is that the tail is what's to the left. So you have this curve where there's a tail over here on the left. And if you remember, you're going to have mode, median, and mean. Kind of in those areas. So mean is to the left of the median. That's what you need to remember. The mean is to the left of the median in a skewed left visualization of the data. Now, skewed right is exactly the opposite. If you notice, the tail goes off to the right. So the clump of data is over here on the left, but the tail goes to the right. And here we're going to have our mode, our median, and our mean. So the mean is to the right on a skewed right visualization. So there's also something called a bimodal. And what a bimodal is going to look like, it means it's going to have two peaks in it. So like a camel's back, right? Then you're going to have uniform, and uniform is, as you can see, all of the information is all right at the same amount. It's all at 12. It's uniform, same data across throughout. Now, here's some more information just showing you they do a better job of drawing than I do, where the mean and the median fall in these graphs. So in the center, we have the normal, where mean and median are the same, and it's right there in the center. To the right of our normal distribution is our skewed right data. And this, remember, has the tail that goes off to the right. And the mean is to the right of the median. Now on the left, we have our skewed left data. Okay, and the mean is to the left of the median, and the tail goes off to the left. Now, remember, we talked previously about center of measure. Center of measure, when you get to a normal set of data, mean or median is a fine center of measure. But if you have a graph that's going to be skewed one way or the other, you need to use the median for the center of data instead of the mean, okay? If the data is skewed, the median is the best measure of center, because there's a lot of data over here on this side. Half the data is over here and half the data is over here. Okay, so median is the best measure of center. Oops, went a little too far. All right, so we're going to use statistics now to compare two sets of data. So up on the screen, we have Mrs. Johnson's class and Mrs. Smith's class, and they both teach Algebra 1, and they just took a test. And these are all of their students' test scores. Now I counted, and they have 14 students in each of their classes, because there's 14 test scores in each line. It's important to count, because even though it looks like it may be the same, it may or may not be. So you always need to count both of them to make sure. Now, the questions are, we need to find the class average, which, remember, is the mean, which means we're going to represent it with an X bar, right? For Miss Johnson's class, and calculate the class average, or the mean, for Miss Smith's class. We need to calculate the range, not the IQR. Remember, the IQR is the interquartile range. This is simply the range, which is the highest, the max, minus the minimum. That's how you calculate range. And then calculate the mean absolute, ooh, that's not good, the mean absolute deviation for both Miss Johnson and Miss Smith's class. So we'll abbreviate that, MAD, mean absolute deviation. All right, so the first thing we need to calculate is the average or the mean. And how do we do that is we add all these up. So I want you to plug into your calculator each one of these, add them up, pause it if you need to, okay? I've already gone ahead and added them up and I got 1,196 for Miss Johnson. And divide that by 14 is going to give me 85.428. So it doesn't tell me what to round to. I'm going to round to the nearest whole number, okay? Because that's usually when we give grades, we round to the nearest whole number. So 85. And now for Miss Smith, when I added all of the grades in her class up, I got 1,230, and I'm going to divide that by 14. And that gives me, let's see, 87.857. So these are actually pretty close averages, 80, I'm going to round up to 88. It's just going to make the mean average deviation easier if I have whole numbers here. And since they didn't tell me what to round to, I get to choose for myself. All right, so I have the mean for Miss Johnson's class is 85, the mean for Miss Smith's class at 88. Now I need to find the range. I need to subtract the maximum from the minimum. The maximum here is 90 and minimum is 74. So 90 minus 74 is 16. Now for Miss Smith's class, the maximum is 99, very close to 100. And the minimum, is there 60 anything? No, it's just going to be 72. So everyone passed. That's good. And then the range there is going to be 27. So we've got the range of 16, range of 27. And then the mean average deviation, I actually went ahead and subtracted the mean from each piece of data here. And I have Miss Johnson's absolute deviation in blue and Miss Smith's absolute deviation in purple. And I've even gone ahead and added them up for us. So all we have left to do is to divide these. So 41 divided by 14 is going to be 2.928. 2.928, and then 96 divided by 14 is going to be 6.857. 6.857. So the mean average mean absolute deviation is, let's round to one decimal place. So 2.9, we rounded to the tenths, and in this one, 6.9. All right, so mean absolute deviation. This can tell us a lot of information. So even though we have these averages that are very similar here, we can see that the spread, the range is much larger for Miss Smith's class. And even with the absolute deviation, we can see that on average, the people's test scores deviated from that average a lot more than they did in Miss Johnson's class. So Miss Smith's class is a lot wider spread. So based on the data, we can tell Miss Johnson and Miss Smith's class have similar averages, 85 and 88. However, Miss Smith class has a higher mean absolute deviation. So her students' test scores are more spread out and less consistent. So even though Miss Smith's class has a higher average, the students in Miss Johnson's class show more consistent knowledge. So that's what interpreting this data is. You take all of these numbers that we have figured out, and you're going to write a few sentences about it when you're asked to interpret the data. Okay, so you just got to give an explanation of what the numbers mean. All right, so now I've got a question for you. I want you to figure this one out. John has a golf score of 88, and he's got a mean absolute deviation of 9.2. Now, Avery also wants to try out for the golf team. His average golf score is 86, and he has a mean absolute deviation of 2.5. So out of these two boys, which golfer should the coach choose and why? Which one would you choose if you were the coach? Well, I don't know about golf, so but I assume that the higher score is better. So I'm going to assume 88 is better than 86. But when we look over here at the standard deviation, look at that, 9.2, the mean absolute deviation, 9.2. And the mean absolute deviation here is 2.5, 2.5. So which one has a higher range, do you think? Well, John's going to have a much larger range, 9.2. That means even though he has this higher average, he could score much lower than Avery, but also much higher. So it's kind of like you never know what kind of game he's going to have. He could have a horrible game with a really low score or a great game with a really high score. Whereas Avery, 2.5, he really sticks close to this 8.6. He's sticking close to it, so he doesn't deviate too much from this 86. So I would say if it were me and I was the coach, I'd go with Avery because he consistently puts out what I presume to be a good score. All right. So last question here, comparing data. Lisa and Deborah have some homework scores, and we're going to ask you some questions about their homework scores. First, we need to calculate Lisa's mean absolute deviation, or MAD, and Deborah's mean absolute deviation. And then based on this, which student has the more consistent homework scores? All right, so I counted these up. Lisa has 14, Deborah has 13. So it looks like Deborah must have missed one assignment, or maybe Lisa did an extra credit assignment. I don't know, but Lisa has one more assignment than Deborah. So it's always important to count them. Just because one has 14 doesn't mean the other one does. So you have to count them. Now, I've gone ahead and I've added all of these up, and Lisa's adds to 1270. 1270 divided by 14 is going to be 90.71. 90.71. So let's just call her mean 91 because I like nice round numbers. All right, and Deborah's added to 1120. Divided by 13 is going to give us 86.15. Ooh, that's much different. So let's call that mean. Let's call it 86. All right, so finding the mean is the first step in the mean absolute deviation. You actually have to find the mean twice in a mean absolute deviation. Now we need to find the absolute deviation. So the difference between the mean and each piece of this data. So you're going to take 91 and subtract 90, take 91 and subtract 95. And remember, you're finding the absolute value, so none of it's negative. And you're going to do the same thing with the second set of data. 86 minus 100, 86 minus 97, 86 minus 72. And again, you're going to find the absolute value, so there's no negatives whatsoever. I've gone ahead and found all of these absolute deviations for us, and I've even added them up. So I've subtracted, and then I added. So here I got 34. Now, what is 34 divided by 14? Because this is, again, the mean absolute deviation. We found the absolute deviation. Now we need to find the mean, or the average, of all of these absolute deviations. So how do we do that? We add it up and we divide by how many there are. So 34 divided by 13 is 2.43. And then 142 divided by 13, because remember there's only 13 grades in that one, is 10.92. So let's see, calculate Lisa's mean absolute deviation. It was 2.43. Calculate Deborah's mean absolute deviation, 10.92. Now, based on these mean absolute deviations, which student has a more consistent homework score? Well, the answer is obviously Lisa, because the mean absolute deviation is lower. That means she sticks closer to about having the same score all the time. So she produces consistent work. Whereas Deborah, she's hit or miss. Sometimes she's really good at her work. She got 100. And then sometimes she's not so good. She got 62. So Lisa is a more consistent student. All right, that's it for today's lesson. And I hope you get through your, you have a practice assignment as well as a quiz coming up. So get to doing both of those. You're going to do great. And I'll see you at